Hello, everyone, and welcome to episode 3 of Terpenes and Testing, the podcast. This broadcast is brought to you by Mace Media Group and Terpenes and Testing magazine, of course, the industry's first publication dedicated to cannabis science. I'm Jason Lupoi, and I'm the editor-in-chief of Terpenes and Testing magazine, and I'll be your host as we navigate across the landscape of cannabis and psychedelic science. For our third guest, we're speaking with Dr. Robert Strongin, professor of organic chemistry at Portland State University. Dr. Strongin joined the faculty at Portland State University in 2007 and additionally received affiliate appointments in both physiology and pharmacology at the Center for Spatial Systems Biomedicine at the Oregon Health and Sciences University, where he has several ongoing research collaborations. In 2009, he served as a Sigma Chi national lecturer. He has earned several awards and honors since joining the faculty at Portland State University, including the John Elliott Allen Teaching Award, Outstanding Researcher Award in the Physical Sciences from Sigma Chi Columbia Willamette Chapter, and the Portland State University Presidential Career Research Award. Dr. Strongin's research group has been one of the few groups looking to educate us on product safety and potential hazards in the cannabis industry and with cannabis products, such as those found from dabbing concentrates at ultra-high temperatures. Dr. Strongin got into studying cannabis vaping from his past experiences in investigating tobacco vaping. Once he saw what was in the aerosol of an e-cigarette, his interest migrated to cannabis vaping because of its surging popularity. And dabbing was of special interest to Dr. Strongin because of its uniqueness to our industry. Welcome, Dr. Strongin.
Thanks so much for having me. It's great to be here. Thank you.
So we had spoke before about some of your research papers that have evaluated the types of molecules that are produced when people are ingesting cannabis using different forms. And in particular, there was a study in, I believe, ACS, the journal ACS Omega, that talked about the toxicants formed from dabbing. If I remember correctly, that was specifically a terpene formulation. And was there CBD in that formulation as well?
Yeah, our first paper was just mainly focused on terpenes,
Okay.
and the subsequent papers have been on both terpenes and cannabinoids, mainly THC and terpenes.
And so I guess overall, what hazards have you found in the aerosol from a dab that warranted concern?
Well, it's really interesting. There are a lot of chemicals produced during dabbing, and it's really hard to assess the toxicology. What we've looked at so far are mainly the gaseous compounds that are produced, because those are what the FDA calls the HPHCs, or chemicals of high concern, and harmful and potentially harmful chemicals. And for those, we don't see, even with dabbing, and less so with vaping, we actually see less toxicants than from smoking. And so in that sense, it relatively speaking, from the toxicants that have been studied, it looks like even dabbing is the emissions are of these volatile organics are lower overall. That's not to say that there aren't a lot of other things in there that we don't know about yet. Either they're in the particulate phase of the liquid droplet phase, which we haven't really gotten to yet, but we're doing that now, and other molecules in there whose inhalation toxicology isn't yet known. So from what we do know, from the chemicals we're familiar with that have been studied for a long time, we know that there are fewer of these volatile organics produced overall from dabbing and vaping, less so even from vaping than compared to smoking. The interesting thing is, we kind of forgot that cannabinoids are actually terpene phenols. So they're actually also terpenes, they're terpenoids. And we were a little surprised to see that we got many of the same products formed from dabbing and vaping, from both terpenes separately, and from the cannabinoids from THC, vaping and dabbing it separately from the terpenes. We got many of the same gas phase products from each, and then realized, well, that's supposed to happen. The THC actually has a limonene looking left half of it, for lack of a better descriptor. The left third or so of THC looks like a limonene fragment. So, and that's usually where the fragmentation occurs during heating.
So,
And
what were some of the molecules that you said you were able to detect from that were common to both terpenes and cannabinoid degradation products?
well, the main one, the one that we found that's common to most all of them, is isoprene. And isoprene is the building block of terpenes. So all terpenes are, biosynthetically biosynthetically made through isoprene units. So yeah, it's not really that surprising that they would degrade to a lot of isoprene, and then some other I wouldn't say common, but some suspected air pollutants and other things that we've looked at, some carbonyls, reactive aldehydes. We haven't seen acrolein, which is probably which we do see consistently in e-cigarette vaping, tobacco vaping, I should say, but not so much in cannabis or cannabinoid or terpene vaping and dabbing. What we see instead is interesting. It's methacrolein, which is less toxic as far as we know. There hasn't been a huge amount of work on it, but it's way less toxic than acrolein. Acrolein is a really great concern for lung health, and it doesn't look like it's really produced so much during vaping and dabbing that the cannabis concentrates. It's interesting because we've known for years what's in the smoke of when people smoke flower. We know what's in that smoke when it comes out, and it's quite different. But we never really knew what toxins that are formed in that and that are present in that smoke came from which molecules, because the concentrates are simpler in their ingredients. So we're actually able to tease everything apart and find out what toxicants and what levels of toxicants can come from each of the components. So we can really trace back some of the breakdown products that occur during vaping and dabbing to specific ingredients, which is what we've been trying to do, so to help promote harm reduction.
Is there a temperature at which you could point to that would be more suitable perhaps for this type of cannabis ingestion in a vaporizable form, where you did not see, at least for the degradation products that you were looking for or quantifying, was there a temperature that was kind of the upper limit that one should be using?
What I would say, everybody has kind of a different vaping and dabbing style, and I'd say just the advice I'd give, again, I'm not a medical doctor or anything, but what I can say for sure is, in general, very generally, the lower the temperature one uses, the safer things are, the more intact the initial ingredients are going to stay, and there are fewer surprises. That said, what's really coming to fore in both the tobacco and the cannabis vaping fields, but mainly in the tobacco field, because it's been around longer, is that sometimes the components, especially some of the metal components, coils, things like that, they can leach. And it's been shown that some of the metallic heating coil materials, canthal and others, can actually act as catalytic surfaces. And so when that happens, this is why it's so hard to pinpoint a temperature, because different devices are going to have different metal surfaces or different surfaces, completely different. And once you start to catalyze reactions, basically what that's doing is lowering the temperature at which the reactions occur. So it's kind of hard to pinpoint one really kind of safe temperature based on, it's going to be based on the user, the device. The higher the quality device, probably the better in general. As well, the better the components, the more reliable the device would be over time. So I'd say the components in the device itself actually contributes to sort of the specific temperature. Again, the lower the temperature, the better.
Okay.
Sure.
You mentioned the lower the temperature, the more intact the target molecules might be. And if I remember correctly, one of your papers evaluated the effects of myrcene on toxicant formation during both dabbing and vaping. And I remember that the results were pretty divergent. Could you talk about that? If I remember, the way it worked, the more myrcene in the concentrates during dabbing, the more toxicants, but you saw a reverse mechanism in vaping.
Yeah, it was really, again, it was one of those things that was really shocking at first because, as you said, the results were divergent. We were thinking after doing the dabbing work that the terpenes, myrcene specifically, but the others as well, actually contribute to more of these volatile organic gaseous toxicants. And it looked like they really contributed to the majority of these gas phase toxicants compared to the cannabinoids. Interestingly, when we went to vaping from dabbing, it was just the opposite. And now the presence of the terpenes actually resulted in fewer overall toxicants that were formed in the gas phase. And the explanation, it's like, oh, okay, it has to make sense. Dabbing, you're just using a surface, and so viscosity and these other considerations, they don't really matter as much. But with vaping, you have to do you need a wicking component, and so viscosity can really hamper the wicking and therefore the heat transfer efficiency. So the temperature will go much higher without efficient wicking. And so when something's very viscous and very oily, it doesn't really flow. It's kind of hard to wick. And so that's an issue in cannabis more so than tobacco, because cannabinoids are highly viscous themselves. So what happens is the terpenes actually act as a kind of a solvent, and they moderate the viscosity. And that makes, in the vaping device, it makes the entire cannabis formulation easier to wick and therefore vape without excess heat, because the wicking is more efficient. I hope I explained that clearly. But yeah, it acts as a solvent, so it makes everything easier to aerosolize, because it moderates the viscosity and the thickness of the cannabinoids themselves. So having the terpenes in there for vaping is actually the right amount. And we use about 10% terpenes, 90% cannabinoids in our experiments, and that seems to really help. The more we went up to about 14% myrcene, and as we went up, we actually saw fewer and fewer of the toxicants formed in the gas phase that a user would be exposed to. Again, just really because it's moderating the viscosity. I don't know if that's the entire explanation, because terpenes can have antioxidant properties too. So it may be that they're also scavenging some free radicals that are and inhibiting some of the oxidative reactions that cannabinoids and terpenes undergo. So they could be acting as antioxidants as well during the reaction. But because it's the vaping and dabbing are opposite, and the main difference is this, just the the device and how things are aerosolized. You don't really need the wicking on the dabbing surface. So yeah, there the terpenes actually are more reactive, which makes sense, and then compared to the cannabinoids. But again, the viscosity and the wicking efficiency is such an important feature of vaping devices that having the terpene, you absolutely need the terpenes. Unfortunately, that's why people also put vitamin E acetate
Right.
to get that viscosity looking correctly. So it's an issue, and again, it's harder in the cannabis field. Again, I think I said this: the cannabinoids boil and vaporize at much higher temperatures than the nicotine and tobacco vaping products do. So you really have to have good wicking efficiency. What happens if you don't is that you get hot spots on your heating element, and that'll really burn your, if you want to call it e-liquid, and really lead to a lot of degradation.
So you also mentioned particulates forming, and we had talked about nanoparticles, and I was wondering what types of molecules the nanoparticles are. What are the main compounds that are being turned into particulate, and what are people breathing into their lungs?
That is a really great question, and I think a lot less is known about that right now. Although there have been a couple of papers that have come out, but a lot less is known about the particulate phase. So the aerosol really, what the big plume we inhale or seeing people exhaling is really two phases. It's a gas phase with droplets, liquid droplets, which is the particulate phase, together. So you have these droplets, which are kind of solidish, surrounded by, well, really liquid solid phase, and surrounded by these gaseous molecules. And so you can get nanoparticles, all different sizes. I know with tobacco vaping, you do get nanoparticles and also microparticles. I think some of the vaping, cannabis vaping papers have shown some of the size ranges of particulates that could be somewhat concerning. Now, what's in the particulate matter is another story. That's actually harder to do and to understand, but there are people out there working on that. It's going to be, composed of essentially the chemicals that we're seeing just as we're looking at the emissions. So whatever is in there to start and whatever it breaks down to is fair game to go into this liquid droplet phase. Typically, though, we can there are models out there where you can predict if a molecule is going to be partitioned into the gaseous fraction, and like a volatile organic, or into the liquid droplet or particulate fraction. The cannabinoids are found in the particulate or liquid droplet fraction. And these other kind of gaseous air pollutants, very small volatile molecules, are found in the gaseous fraction. And we can separate those and see what's in each. And so actually, it can actually predict typically based on molecular structure, vapor pressure, boiling point, polarity, water solubility, even sometimes, whether a molecule is going to where a molecule is going to partition, which is really important because the gaseous and the liquid droplet deposit in one's in one's respiratory tract at different locations. And so a lot of the really tiny water-soluble molecules like formaldehyde that are formed, a gas is going to mainly deposit in the upper airway, in the throat or mouth, etc. area, whereas cannabinoids will go a bit more deep into the lungs. But then again, in the droplet phase, the smaller the particles, the farther down they usually go into the lungs, which can be quite concerning. So it's really, you ask a great question. It's really important to know what's in that phase. I can say that the particulate phase is where we have the cannabinoids for the most part.
Okay, great. We've only got about a minute left. I just wanted to touch on any current projects that you might be working on that would kind of add to the body of research that you've already contributed.
Yes, thanks for asking, Jason. We're working on the cannabinoid and terpene chemistry, but focusing now on some of these newer cannabinoids that are getting popular, like the acetates and some of the other cannabinoids that are out there. Delta 8, for instance, Delta 8 THC, and the THC and CBD acetates are compounds. There's chemistry we're studying right now and that we're finding to be really interesting. We hope to have a publication out very quickly, especially on the acetates. I don't want to spoil anything, but we have some pretty important results on the acetates, on vaping the acetates. They're pretty unstable.
That definitely sounds interesting, and I'm going to be keen to read those papers when they come out. Dr. Strongin, I'd like to thank you for being my guest today.
Thanks so much, Jason. I really enjoyed it, and appreciate you having me.
Well, I think this has been great information. I appreciate your scientific curiosity in evaluating aspects of cannabis consumption that we may not always want to hear, but that we should welcome with open lungs. And of course, I'd like to thank all of you listeners for tuning in. We'll see you next time on Terpenes and Testing, the podcast. Until then, please come visit us at www.terpenesandtesting.com or on one of our social media platforms. Cheers.